Hi, geometry students. Let's get going with section 11.2. Hopefully you found 11.1 pretty easy, except maybe a little occasional side work. Section 11.2 is areas of trapezoids, rhombi, and kites. Again, we talked about these when we talked about four-sided figures, but we didn't talk so much about the areas. So first of all, a trapezoid, you hopefully remember that it is a quadrilateral, so a four-sided figure. It has two parallel sides called the bases. So these two guys are parallel, base 1 and base 2. They're always the parallel sides, so watch for those. Sometimes, you know, they'll draw the diagram sideways. Turn your head sideways if you have to. These other two sides are slanted. Sometimes if they're congruent, it's an isosceles trapezoid. Sometimes they're not. But the important thing here is we just need to know how tall that trapezoid is, so we have to have a height. The formula is a little bit different on this one. It's not difficult. You just take your area, make it equal to the sum of the bases multiplied by the height, and then divide by 2. So base 1 plus base 2, get that sum, multiply it by the height, divide by 2. Some people like to write it as the area equals 1/2 of the sum of the bases times the height. I prefer over 2, but you are welcome to do whichever way makes more sense to you. So there's our formula. We'll do some practice problems, but let's move on to rhombi. So rhombus is a shape that has opposite sides, parallel and congruent. If you remember, a rhombus is a slanted square. I should say that all 4 sides are congruent. I'll say 4 congruent sides. They're also parallel, so these guys are parallel, these guys are parallel, but notice they all have the one dash, the one congruent dash. Kites are also four-sided figures. Maybe you remember the adjacent sides are congruent. So consecutive sides, or the sides that touch each other, the adjacent sides. So these two sides are congruent, and then these two sides are congruent. Any way it goes, we have a nice little formula that applies to both of them. So the formula for a rhombus or a kite is equal to A is equal to D1 times D2 all over 2. Now it's important to note here that the D stands for diagonal. So you've got 2 diagonals in every four-sided figure. So the one diagonal times the other diagonal divided by 2. Again, some people might prefer to do the area of a rhombus or a kite is equal to 1/2 times the diagonals multiplied together. Please notice these diagonals are multiplied. In the trapezoid, the bases are added. So just little sign things watch out for. So let's do a couple practice problems. Let's see what we got here. Well, let's start with a trapezoid. So number 1, find the area of the following figures. So it tells us, notice here's our 2 parallel sides. So area is equal to the sum of the bases times the height all over 2. We can easily substitute some values in here. Area equals, does it matter which way you add 18 plus 40? You're going to get 58 no matter which way it goes, right? So it doesn't matter which way you put those into the formula. 40 plus 18 is the same as 18 plus 40. So that area is going to end up being, when you get to your calculation, something like 435 square meters. Right? It's just plug and chug. You just need to figure things out. Number 2 looks a lot like a kite to me. So if we've got a kite or a rhombus, it doesn't matter which. Remember, our area is going to be equal to multiply your diagonals all over 2. Well, this one's pretty much shouting at you. One diagonal from this side to this side is 15. The other diagonal is 8. So all we do is 8 times 15 all over 2. It doesn't matter if it's 8 times 15 or 15 times 8, right? Does not matter. I'm going to jot down over here. This is a kite, just in case you need to know where I got that formula from. That ends up being 60. And if we're going to put the units on there, that would be meters squared, because area is always squared. So far, so good. Everybody okay? Seems so easy, right? We throw some side problems in here. This one looks to me like it's going to be a rhombus. I know that because the diagonals got bisected. I also know that that happens to be a right angle, which isn't marked. Just be careful on this one. Our formula for a rhombus or for a kite is the product of the diagonals over 2. This one, your diagonals are not 6 and 7. This 7 is centered on this section, so this whole diagonal is 14. This whole diagonal is going to be 2 6s or a 12. So I'm going to do a 12 times 14 all over 2. So the area of this rhombus is going to be somewhere around 84 millimeters squared. Everybody's good. This seems easy, right? All right, so let's make you think a little bit. This is way too easy for you. Number 4, it says rhombus RSTU has an area of 64 square inches. Find US if RT is equal to 8. So here's US. I'm going to put an X on there. Here's RT. They tell us that's 8. And they also tell us this. So if we think to ourselves, diagonal 1 times diagonal 2 all over 2, we actually have a number to put into the area. 64 is the area. So I'm going to put a 64 in here. One of my diagonals is 8. The other diagonal is X. That's all over 2. So I'm finding the length of a diagonal, US, so I have to work backwards a little bit. I'm not sure which way you're going to solve this. If you just notice that there's a 2 in the denominator and you don't like fractions, so you're going to multiply both sides by 2. Perhaps you're one of those sneaky people who noticed that you could have done 8x and divided by 2 and got a 4x. Anyway it goes, you'll get the same answer. After you divide, you will always get x is equal to 16. And that's just in inches because there is no square. We already know the area. We're finding just the length of one of those diagonals. All right, we do the same thing for number 5. It gives us the area. And we want to find one of the diagonals. This one happens to be a kite. This one happened to be a rhombus, but it's the same formula, so it's the same idea. Let's see what else we've got. Oh, we've got some nice curvy figures. So let's see, in this problem it says to find the area of the figure. Well, we got a couple things. We could do you see that it's a trapezoid? I switched it, I turned it sideways. If I want to look at it this way in this top right corner, I've got the parallel bases. So I could use that trapezoid to find the area of the figure. Only here's the problem. I got some missing lengths, right? I know that this is X and this is X right here. Let me highlight those guys. And I know that this is L, but I know that the whole side is 10. So if I could find X or if I could find L, I could find out the other one. So here's the thing. I see a teeny bit of perhaps a side Pythag problem. If I take this part of the problem out, I'll just take all that out of there. Oh, except I erased my 4. I think there was a 4 right here on this dotted line. Do you see that I could do Pythag if I use that triangle, that right triangle that is the top portion? I turned it sideways here. So L squared plus 4 squared equals 8.5 squared. I can do myself a quick problem. So I'm going to do L squared plus 16 equals whatever that is. I'm going to just jump ahead, check my math, make sure I'm right. I'm going to say that L is equal to 7.5. I believe it comes out to a nice, neat number. Some people don't like using L's there because they look like ones and they're weird. Put a Y, put a T, put whatever you want for that. So if I know by doing Pythag side work that this segment right here is 7.5. Could I figure out what the x is? The whole side's 10, right? So x has to be 2.5, and this has to be 2.5. Now my question is, do you want to do this as a rectangle and a triangle, or do you want to do it as a trapezoid? Because just like in section 11.1, we could add the areas together, or we could just do one big trapezoid. I'm guessing that most people are going to want to do it in two separate sections. So you're probably going to want to figure out what the area of this guy is. Base times height divided by 2 for a triangle. And then we can find out the area of this guy, base times height. We just found the height, so that's really helpful. Add those two areas together. So we could do area of the triangle plus the area of the, area of the rectangle. So the area of the triangle would be, what, base times height, so 4 times 7.5. I'll put that in parentheses so the dots don't mix up. All divided by 2. So I think that's going to be about 15. Area of the rectangle, this guy right here, is going to just be a simple 4 times 2.5. No dividing by 2 in that one, so that's a 10. So the area of the whole shape is going to be 15 plus 10, or 25 square inches. If you had wanted to do it as a trapezoid, the whole problem, we needed to know this x. We needed to know that that was 2.5. So we could do our two bases. So the trapezoid is base 1 plus base 2. So 10 plus 2.5 multiplied by the height 4, all divided by 2. I'd be willing to bet that comes out to a 25. There's more ways to do this than just one way. All right, let's skip up to this one. Number 8, it's a word problem, right? One diagonal of a kite is twice as long as the other. If the area of the kite is 275.5 inches squared, find the lengths of the diagonals. Okay, so I'm going to try to draw a kite. I'm going to try to draw in the diagonals. I know this is one diagonal, this is the other diagonal. Maybe I'll move this guy up here. So if I know that one diagonal is twice as long as the other, couldn't I say that this one is x and this one is 2x? And I know that the area is 275.5 inches. So area equals d1 times d2 all over 2. So I know the area. Is anybody going to object if I put in a 0.5 instead of 1/2? d1 is x times 2x all over 2. Do not be intimidated by x's. We know how to do this. I'm wondering if you're not going to like those over 2's, so you're going to times by 2 to cancel that out. That's going to be like 551 when I multiply 275.5 times 2. X times 2x is 2x squared. So I'm going to solve this. This is not a quadratic. I do not have a plain old x. I could square root if I get rid of this 2 first. So I'm back to a 275.5 equals x squared. And then my last step, we all know, is to square root. It's probably not going to come out super nice. It's going to come out to something like 16.60. I always go to 2 numbers after the decimal. So one of them, this diagonal is 16.60. Could you figure out this diagonal right here? The other one would have to be 2 times that, right? So somewhere around 33.2. 33.20. I think it'd be inches, isn't it? Yes, inches. There we go. Good word problem, but if you label it and draw it, you can figure things out. That is it for section 11.2. The fun just never ends when we're doing these. Let me know if you need anything, and we've got this.